Hello and welcome. In this video, Sneo and myself will walk through Oracle DataGuard Fast Start Failover, or FSFO for short. We'll start with a high-level overview of how FSFO works and then finish with a simple demo showing it in action. Fast Start Failover automates database failover to maintain high availability leveraging Oracle DataGuard. It continuously monitors your DataGuard environment and automatically performs a failover in the event of an outage. This greatly reduces recovery time and the manual effort of reinstating the failed primary. Let's start our discussion with a simple failover scenario. When a primary database fails, a notification goes to the monitoring team. Hopefully, they contact the DBA, who picks up the phone, and hopefully the DBA requests access, waits for approval, logs in, investigates, raises a change request, waits again, and finally performs the failover. All of this counts towards your recovery time objective, or your RTO, and the DBA still needs to reinstate the failed primary. This is where Fast Start Failover comes in. It automates failover entirely. It uses an observer that monitors the DataGuard configuration, and when the primary becomes unhealthy, it automatically triggers a failover, cutting recovery time dramatically. The failed primary is automatically reinstated as a standby. FSFO operations are centralized through an Oracle DataGuard broker, which simplifies management, monitoring, and failover actions. You can use Oracle Enterprise Manager Cloud Control or the command line DGMGRL interface to manage the configuration. When DataGuard is set up through Cloud Tooling, the broker configuration is created automatically. To enable Fast Start Failover, connect using the DGMGRL command line and run enable Fast Start Failover. Once enabled, the broker expects the observer process to be running. If it's not, you'll see a warning about the missing observer. Running a status report on the primary confirms that the warning is due to the observer not being active. For testing, without impacting production, you can use the Observe Only mode. And you would do this by issuing the Enable Fast Start Failover Observe Only to the DGMGRL command line. This mode lets you safely validate failover triggers and timing without any real failover taking place. The observer itself is a lightweight OCI client, and it's included with the Oracle Database Client installation. It's the key component that enables automatic failover in Fast Start Failover. The observer can run on any host, ideally on a separate system, and really from a different location for resiliency purposes. So for example, if your primary and standby databases are in Availability Domain 1 and Availability Domain 3, you could run the observer in Availability Domain 2 for additional fault isolation, or even in a different region. You start it by connecting to DGMGRL and running Start Observer. For production, it's best to wrap the startup command in a script so the observer restarts automatically when the system starts. The observer's primary job, as we said, is to initiate automatic failovers when the primary database becomes unavailable, and to do so only when data durability policies are met. Its secondary role is to automatically reinstate the failed primary as a standby when that feature is enabled. This slide shows the verbose mode of the show configuration command, and it provides FSFO specific information. If the status is marked as success, you're ready to start testing role transitions. Use the show Fast Start Failover command to see which user configurable FSFO failover conditions are in effect. For a Fast Start Failover to occur, there are core conditions that must be met. The observer obviously needs to be running and monitoring the environment. The observer and standby will have had to lose contact with the primary. The observer is still in contact with the standby. All durability and protection constraints need to be met, and the failover threshold timeout has also elapsed. In Oracle 11g and later, you can also configure specific database errors or custom conditions that trigger failovers. For example, user-defined failover triggers, including specific Oracle errors, and even application-initiated triggers. You can use the Observe Only mode to test policies and tune your configuration so you can confidently reduce downtime without accidental or unnecessary failovers. Cloud Tooling allows for easy DataGuard setup, but currently doesn't fully automate FSFO for all base DB and Exadata setups. If you manually enable FSFO in these environments, Cloud Tooling functions may be temporarily unavailable until failover roles have been synchronized to the control plane. Oracle DataGuard offers 3 protection modes, each interacting differently with Fast Start Failover. With maximum performance, DataGuard uses asynchronous redo transfer. This means there may be a risk of some data loss. FSFO will not trigger automatic failover if the potential for data loss is too high. Maximum performance mode provides flexibility to trade availability for performance. Commit latency isn't affected because redo is sent asynchronously, but any committed transaction whose redo hasn't yet reached the standby could be lost during a failover. To control this, FSFO lets you define the maximum allowable age of transactions that can be lost. So for example, if the limit is set to 30 seconds, which is the default, FSFO guarantees that all transactions committed more than 30 seconds ago are preserved. The minimum configurable limit is 10 seconds. Now in maximum performance mode with Fast Start Failover, the primary continuously computes the lag with the Fast Start Failover target. If the standby is not reachable or is slow, the primary keeps committing until reaching the lag limit that has been defined. After reaching the lag limit, it then goes into a stalled mode, so no more commits are possible. The observer sees the primary stalling and resumes its activity over the lag limit. However, no failover is possible with this status. When the standby catches up with the primary automatically goes back under the lag limit, and at the next check the observer acknowledges the change and failovers are then possible again because you are back within the limit defined. Maximum availability is another DataGuard protection mode. It's like the maximum protection mode, but if the standby connection is lost for a specific timeout, the primary enters a stalled state. If communication resumes, everything continues as normal, otherwise the system protects itself until safe failover is possible. Let's see the usage of configuring max availability without and with FSFO. In the case of max availability without Fast Start Failover, if the standby is not reachable, the primary stalls waiting for the sync destination, so again no commits are possible. And after the net timeout seconds, it resumes the activity without protection. Now if the standby is slow, the commits will take longer, decreasing the primary database performance. Thus latencies, disk and or network have a crucial role. Max availability with Fast Start Failover, the primary never commits without the observer quorum. In a normal situation, the status is synchronized. However, if the standby is not reachable, the primary waits for the sync destination, so no commits possible, but keeps the status synchronized. And after the net timeout in seconds, it transitions to stalled. The observer sees the primary stalling, here we're talking about the quorum with the primary, and then resumes its activity unsynchronized. And in this case, no failover is possible with this status. However, when the standby is in sync again, the primary automatically changes the status to synchronized. And at the next check, the observer acknowledges the change. Failovers are possible again. Maximum protection mode is the third of the 3 DataGuard modes, and the primary never commits unless standby and observer are synchronized. If connectivity is lost, the primary database stalls to prevent data loss. This guarantees 0 data loss. In the case of max protection without Fast Start Failover, if the standby is not reachable, the primary stalls waiting for the sync destination. No commits are possible. Even after the net timeout, the commits on the primary cannot happen. If the primary is not reachable, failovers, even manual, are safe if no other standbys are protecting the primary. In case of max protection with Fast Start Failover, the primary never commits without the observer quorum. In a normal situation, the status is synchronized. If the standby is not reachable, the primary waits for the sync destination but keeps the status synchronized. After the net timeout seconds, it transitions to stalled. The observer sees the primary stalling and acknowledges the new status. If the primary is not reachable, the primary never committed without a sync standby. The automatic failover is always safe, but the new primary will require another standby to keep the current protection level. Here are some useful resources for your reference. Now I'm handing over to Sneha for a quick demonstration of Fast Start Failover.